Now let's look at prediction intervals. There are two ways of developing prediction interval. If we can assume normal distribution for forecast errors, then we can take the forecast and then do plus or minus normal distribution table value times RMSE, root mean square error, which is an estimate for standard error. So this will give us the lower and the upper limits for our forecast. Or if we cannot assume normal distribution, then you have to take the error values and arrange them from smallest to the largest, and then look at the interval that we want and select the errors from those 2 points and apply that to the forecast to develop an empirical prediction interval. So we'll look at examples of both. So here, let's assume random walk forecast, and let's see how to develop a normal distribution confidence interval or prediction interval. So with 690 being the previous actual value, so we start with a forecast of 690 for the first time period, and then the previous actual value is the forecast for the next time period. Okay, and then the errors are actual minus forecast. Okay, now forecast for 2004 will be the actual value of the previous time period, so that's our forecast. Now RMSE, we can get this is the random walk, so we can get it from the previous tab, okay, which will be the same as, if you go to the previous tab for random walk, here is the random walk, RMSE is that. Okay. But we can also compute RMSE using a different Excel function, which is called sum of squares. Okay, and if we give that range, so that will give you the sum of squares divided by n minus 1. So that will be divided by n, it will be the count. Okay. Okay. And of course this is the squared value, so you have to take the square root of that, and that's the same as that. Okay, so you can use this method also. Now confidence level, so let's say we want 90% confidence level. Okay. Now degrees of freedom is n minus 1, so count of that minus 1. Okay. I know that if you go back here, we use z sub alpha over 2. That's normal distribution. But actual distribution that we should use is t, because to use z, we need to know the population standard deviation. And we make an assumption here that the z will be close to t, and it's an approximation. But since we're using Excel, where we don't have to worry about getting the t-table value, because in the back of the book, t-table value is kind of difficult to get for certain degrees of freedom and confidence intervals. But in Excel, we don't have that problem, so we'll use t value. So there will be t dot inv function will give us the t-table value, and 2t. Now the probability we need to give here is the alpha value, that is the tail area, so which is actually 1 minus the confidence level. Okay, so that's our probability, and degrees of freedom is n minus 1. Okay, so that gives us the t value. Now you multiply the t with the RMSE, that will give us the margin of error. Once you have the margin of error, then we take the forecast minus margin of error will give you the lower limit. Okay. And we take the forecast and add the margin of error, we get the upper limit. So we can say here we are 90% confident that the sales in January 2004 will be between 38.4 and 1181.6. Okay. As you see, this confidence interval is really not all that helpful because the margin of error is so large that it becomes impossible, or it becomes pretty much valueless. So that's the reason why we want to predict in such a way that the errors are kept to a minimum possible value.